Okay, now let's go. All right, as usual, if you guys have any questions, just stop me and ask, clear your doubts. If after this session you guys have questions, you guys can always PM me. All right, now let's go for today's chemistry, right? Okay, now we are going to learn chemistry. For chemistry, we have 7 chapters for semester 1. So we're going to start with chapter 1, matter. So there's 3 subtopics in matter. Number 1, it's definitely the basics. You know, you're going to learn about isotopes and all this stuff. Basically, it's all about your atoms and molecules. Second part, you're going to learn about mole concept, empirical molecular formula. And your third part is the most crucial and the most significant part. You guys are going to learn about stoichiometry. Okay, now, this part is actually quite important because for my paper, it came out about stoichiometry. So very high chances it might come out again, or it might come out this part, because this part, it looks simple, but at times it could be tricky. Okay? All right. Now, first and foremost, let me just highlight over here isotopes. Okay, I'm going to highlight the most important parts for this particular subtopic, okay? Now, number 1, we're going to learn about isotopes today. Isotopes. What's the meaning of isotopes? It's 2 or more atoms of the same element that have the same number of protons in their nucleus but different number of neutrons. Okay, this definition is extremely important because if you guys jumble it up, mix it up, or maybe write over here protons or whatsoever, or orbit or whatsoever, you guys are going to lose marks. This at times it'll be 1 mark, but at times it'll be 2 marks. You never know 2 marks will do what to your particular examination paper. That's number 1. Number 2, I've already highlighted or underlined for you guys all these keywords. Without these keywords, no marks will be provided. That's number 2. Number 3, in chemistry, there's no such thing as if you leave this keyword, they are going to give you 1 out of 2 marks. No such thing. It's either you have it or you don't have it. If you have it, full marks. If you don't have it, no marks. Okay? That's chemistry. Okay, now you guys, that is the perfect definition of isotopes itself. Now, let's go to isotope notation. Okay. Now, when we're talking about isotope notation, you guys know this very well. Dari dulu dah belajar dah. Benda ni, it's like science. No, I'm sorry. It's chemistry. When you guys went Form 4, you guys learn this very detailed. Okay. Now, can you guys say to me, what is A? What is A over here, guys?
Is it
nuclear nuclear number. What is Z?
proton number?
Yep. Okay. Don't wait for your turn to answer. Just answer. If you know it, just answer. I'll be really happy for you guys to interact. Okay. Now, nuclear number. What is the meaning of nuclear number?
Proton plus
Nuclear number.
Yep. Neutron. Okay. Your nuclear number is basically your proton plus your neutrons. So these two is actually in your nucleus. That's why the definition of isotopes is so. That's number 1. Number 2, this is your proton number. So when this is your proton number, you guys know nuclear number is proton plus neutron. So definitely by deducting your proton number, you can automatically get your neutron number. Okay? X is any atoms or ions or whatsoever which symbolizes from the periodic table itself. Okay, now an important note for you guys to take over here is chemistry formula wajib. No such thing as they giving you the formula. You have to know the formula before even entering the exam hall. That's number 1. Number 2, kalau tak tulis formula, tiada markah langsung. That could be your case. Or number 3, kalau tiada formula, they will deduct marks from your formula sebab tak tulis from formula, and then maybe the rest working, they might give you the marks. Okay? So that's chemistry. Any question before we move on to the next slide?
No questions.
All
No
right.
question.
Thank you. Now, let's go to this part. This is number 2. This one is memang penting lah, because this one holds the whole subtopic, the first subtopic for your whole chemistry chapter 1. Okay. Now, you got to know very well what is relative atomic mass, what is this symbol, what is this, and what is this. Because this is going to determine how you calculate whatsoever I'm going to teach you next. Okay. Now, let's have a look. Relative atomic mass. Relative atomic mass is one atomic mass. So mass unit equals to 1/12 the mass of carbon-12 atom. Okay. Now, what does it mean? Carbon-12 atom, the mass is this. 12.000 atomic mass unit, AMU atomic mass unit. The moment they say mass, you have to write AMU. Kalau tiada, salah. Kenapa? Ini adalah unit kepada mass. Okay, that's number 1. Number 2, what do they mean by 1/12 over here? So, 1/12 bahagi dengan 1/12 darab dengan 12.000. What are you guys going to get?
One.
Yeah, 1 exactly. So apa-apa bahagi dengan 1, jawapan dia akan stay kan? It will never change. So that is why number 1 they use carbon-12 atom, because it's perfectly 1/12 of the mass of carbon-12 atom. And number 2, it's not going to disturb the calculation or whatever value that you guys are going to put up here. So that bahagi dengan 1 juga. Okay, that is the first part. Now, let's go to this. AR basically is your relative atomic mass. This one symbol penting tau. If your A and your R is like this, they're not going to accept. And if your A and R is going to be like this, they're not going to accept. Okay, it has to be like this. Okay, now formula ni sangat penting for your next calculation. We are going to learn about something very fun after this. Okay, now relative atomic mass is equals to average mass of one atom of the element. Now, you guys know very well the average mass or the mass of a specific atom ada dalam korang punya table that I have given you guys, right? Let's say macam oxygen is 16 if I'm not mistaken, carbon is 12 and so on. Tapi, the moment they say average, why is it so? Sebelum ni kita dah belajar tentang isotope. So when there's isotopic, maksud dia, there is more than one particular element of an atom. Maksud dia, let's say oxygen is not necessarily going to be 16.8. It can be 17.8, 19.8, 15.8. So average of the values of it, you're going to use this formula to calculate. Okay? We are going to learn it very shortly. Now, that is atomic mass. Now, what's the difference between relative atomic mass and relative molecular mass? As you guys pernah belajar berulang-ulang kali, it's almost the same thing. The only thing different is one is for atom and one is for molecule. Now, when we're talking about molecule, symbols have to be such for your formula. Tak tulis formula ni, 99% of the time you guys are not going to get marks. Okay? Formulas memang wajib. Next, average mass of one molecule of substance. Maksudnya not H, not only Cl. It's HCl. Kenapa? Because right now we are talking about molecule. Kalau di sini, you can talk about H only, you can talk about Cl only. Over here, you have to talk about HCl. Kenapa? We are talking about molecule. Now, same thing over here in your denominator, 1/12 times mass of one atom of carbon-12. What is the mass of one atom of carbon-12? It's 12.000. Maksudnya you darab dengan 1/12, you're going to get 1. So whatever up here stays. Okay? Now, any question before I move on to the next slide?
No questions.
All right, thank you. Now, this is a very fun part. Okay. Right now, we're going to learn about mass spectrometer. Okay. What is actually this mass spectrometer? It's actually a way for you to calculate output. What output we are talking about? It's about the output or the abundance atau quantity a certain type of isotope of an element. You want to calculate that specific quantity of a certain type of isotope of an element. Okay, just hold on. All right, okay, so we are going to talk about certain type, which means specifically about something. Maksud dia kalau oxygen, we are not only talking about oxygen 16, like O16. No, we're going to talk about 17, 18, 15. So those are all the isotopic elements, okay? Now, I'm going to show you guys one video how this thing actually works, okay? Don't worry, I switched on the subtitles so that you guys can see too. Okay, now.
While chromatography separates compounds depending on their chemical and physical properties, mass spectrometry, or mass spec as it is commonly known, reveals a compound's molecular weight. In a mass spectrophotometer, a beam of electrons bombards a single chemical sample with enough energy to break apart molecules. The fragments produced are propelled through a magnetic field and automatically sorted according to their mass and charge. An ion detector collects and records the fragments, producing a graph showing the mass to charge ratio of each. To analyze the information and deduce the structure of the original molecule, a scientist must work backward, reassembling the fragments on paper. When all goes well, they fit together like puzzle pieces to reveal the composition of the original sample.
So now, did you guys see that?
Yeah.
Okay.
Yes.
So that is actually the process of how you get the abundance of one particular isotope. Okay, process to actually you guys do need to know. But in order for you to guys understand, we are going to learn after this about mass spectrometer, we have to actually know the idea, at least the idea of it. Benda tu atau proses tu, how and what actually comes out of that particular machine is not necessarily for you guys to know for our matriculation syllabus. Okay, so now I'm just going to write over here output. We're talking about the abundance of certain isotope of an element. Okay, sorry about my writing again. Okay, all right, so that is the main part over here. This one have to know. Okay, now we are going to talk about average atomic mass from mass spectrometer. How does this thing actually work? Okay, when you guys go to your semester 1, you guys are going to learn this formula. Formula ni sangat-sangat wajib for you guys to know. Average atomic mass equals to summation of Qi Mi over summation of Qi. Now, before I move on, what is Q, what is M? One of the simple ways for you guys to get the idea or to remember this particular formula is just average atomic mass equals to E mi E. That's like the most classic way for us to know. E mi E. Okay. Now, what is Q actually? So now, Q is actually the relative abundance of an isotope. Okay, Q is the relative abundance of an isotope. Maksud dia, let's say we are talking about BB-191. So that particular isotope is 75%. Maksud dia, lepas spectrometer ini analysis from the mass spectrometry, we actually found out that 75% of abundance of BB-191. You guys don't know what's BB? Can check in your periodic table. In the particular isotope. Okay, that is Q. What is M? M is the mass of an isotope. Okay, now Why are we actually finding the average? Sebab walaupun dia isotope number of dia punya number of neutrons or protons or whatsoever, it's different from one another. The main idea for us to do is because they are isotope from the same element. So you have to find the average atomic mass, which means everything you compile bahagi dengan number of representative. Maksudnya let's say dalam satu kelas tu ada 12 orang, you guys nak find average, bagi dengan 12. Same thing over here. Okay? Alright. This is a very important formula. I'll teach you guys how to use this formula very shortly. Okay? Any questions before we move on to the next slide?
No question.
Alright, thank you. Now, tadi korang dah tengok the graph kan dalam video tadi tu. There's like a small graph at the end of the video, right? So, what is the graph about and how do we represent the graph? Number one, the y-axis over here, it's called relative abundance. Maksudnya belah sini boleh jadi 75, sini 50 and so on. Tapi remember, maximum relative abundance, if we are talking about in the volume of percentage, maximum hanya 100. Because percentage definitely, maximum percentage is 100% kan? Okay, let's say, let's take oxygen lah. One type of isotope, that's 25%. The another type of isotope will definitely be 75%. That is how you make up 100%. So, that is how relative abundance works. Abundance, okay? Quantity, bilangan atau kebanyakan dalam sesuatu tempat. Okay, that's number one. Now, the x-axis is called mass to charge ratio. Okay, what is actually the mass to charge ratio? It's actually the number of charge form. So basically, charge ni apa tau? Is actually cation. Cation, when it comes to mass spectrometry, it's always positive 1. Cation kan positive. Sorry, excuse me, just a moment. Okay. So cation kan positive. So the moment is positive, when scientists did the researches, they found out that majority of the time or 99% of the time is positive 1. So mass to charge ratio maksud dia apa? Something bahagi something kan? So the moment you say so, mass, whatever mass is here, let's say 87, bahagi dengan I've said charge, cation, majority of the time plus 1. The moment you bahagi, dia akan still say 87. Okay, so that is the mass to charge ratio. Maksudnya dia, what is the mass of that particular charge? Okay, it can be whatever lah, 16, 17 or so on, but usually dia akan skip 1-2 nombor je. Okay, now how will they usually draw the graph? Usually they akan draw the graph like this. Okay, so ini you guys will learn to draw this kind of graph. You guys gonna learn it in maths semester 2, probability distribution and all those stuff. But for chemistry, you guys gonna know K16, dia punya relative abundance 50. Itu je you guys gonna know. Macam ni je. Okay? No need to complicate your style with mathematics. Okay? Alright. Now, any question before we move on to the next part?
Yeah.
Yes.
Yang cation tu memang dia plus 1.
Okay. Dia not necessarily plus 1. Tapi, as scientists made experiments, and you guys can search on Google, no? This charge, don't worry, benda ni takkan keluar. I'm just explaining so that you guys, get some extra knowledge. Majority of the time, it's positive 1. Because we're talking about cation, okay?
Okay.
It may differ with cases, tapi in our thing, we have to assume majority of the time is positive 1. You guys want to know more about this, you guys can search on Google. Tapi in our syllabus, don't worry, they won't ask what is mass to charge ratio and all the stuff. You guys got to know, benda penting adalah what is the symbol on the x-axis, what is the representative on the x-axis, and also y-axis, and cara nak baca graph ni. Itu je korang kena tahu. Okay? Alright guys, let's move on to the next part. Okay, now this is one of the questions that I would like to do together with you guys, okay? Now, soalan ni very interesting. It's quite direct, tapi how you apply those formulas and all those stuff. Okay. Number one, key points or keywords or benda-benda yang penting you guys have to see before answering the question is relative atomic mass of this isotope and this isotope are this and this. Automatically write like this so that korang tak confused, korang tak jumble up. Atau nak save kan, just write BB-191 is 191.021. Same goes here. Alright, that is step number one. Now, why did I draw this arrow like this? Can you see here respectively? Maksud dia ini adalah untuk ni and this is for that. Okay, that's number one. Number two, soalan dia is what is the relative abundance? Tadi kita dah belajar relative abundance is apa simbol dia?
Q.
Exactly. Q adalah simbol relative abundance. Itu kita tahu terang-terang. Of each isotope, okay. Kalau dia suruh cari what is the relative abundance of each isotope, you can automatically guess that okay, dia tak bagi Q untuk ni, dia tak bagi Q untuk ni. Maksudnya dua-dua Q kena cari. Tapi M dia dah bagi, mass. Okay. Now let's continue. If the relative atomic mass of iridium ni apa? Exactly here. Okay, is 192.254. Okay, ini nombor 2 korang kena tahu. What are they asking? Number 3 is let's start the working solution. Now, before korang start anything, right? Now, you guys have to know very well that they are asking about relative abundance, Q. So, what is the formula that we are going to use over here? Anyone? What is the formula that we're going to use over here?
Average atomic mass.
Yep, exactly. Sebab itu adalah satu-satu formulanya yang you guys belajar, ada iki ni iki, which is there's Q over there, right? So, walaupun soalan dia average, okay, dalam formula average, but here they ask relative abundance and they give you relative atomic mass. Tapi tadi formula average atomic mass. Okay, I'm going to explain to you what is the difference very shortly. Number one, you guys have to know very well that relative atomic mass, average atomic mass, calculation dia formula yang sama. Okay, tapi the only difference over here is you guys have to change it to relative atomic mass. Kenapa? Sebab soalan bagi relative atomic mass, not average atomic mass. Tapi have to bear in mind, the formulas are all the same. Okay? So now, you guys can write iki mi over iki. Okay. Sekarang korang tahu very well Q relative abundance. When relative abundance just now we have talked about percentage kan. So we don't know what is this, we don't know what is this. Dua-dua tak tahu, tapi M kita tahu untuk dua-dua. What is the trick you can use is maths. Kalau yang ni X, yang ni Y. So what you can do is you have to write this tau. Kalau tak tulis ni memang kosong markah for your whole working answers. Okay? Let BB-191 equals to X and BB-193 equals to, okay. Over here, cara paling mudah is 100 tolak X. Tahu kenapa? Just now we have talked about abundance, right? Dalam graph tu abundance, okay? Abundance percentage. When it comes to percentage, maximum percentage is 100%. Kalau sini dah X, sini apa-apa jadi pun akan jadi 100 tolak X, which means the remainder of it. Okay? So, now you guys can fill in all the data into the formula. So, relative atomic mass 192.254 equals to Q. What is your Q over here, guys? What's your Q over here? Anyone? Just have a try. You guys understand right until now? Kalau tak faham just tanya je. Yes?
Yang
Ya.
BB91 kah?
Ya. You boleh ambil yang ini atau you boleh ambil yang ni. Tapi provided BB191 masa darab dengan M tu dekat sini mesti ikut mass yang ini. Tak boleh suka-suka ambil ni. This one is for this one and this one is for this one. So sini kita dah represent BB191 dengan X kan. So X ni apa? Relative abundance tadi kita dah cakap. So the moment we are talking about that, we can put over here X darab 191.021. Okay? Ni untuk BB191, ni untuk BB191. And then you have to tambah. Tambah apa? 100 tolak X. This is the relative abundance untuk 193. Darab dengan 193.025. And then you bahagi dengan belah sini total of relative abundance kan. Tadi kita dah belajar relative abundance percentage. So the moment total tambah berapa ribu kali pun dia akan jadi 100% je. So now I want you guys to find what's the value of X for me. I give you guys 1 to 2 minutes. What is the value of X? What is the value of X, guys? Try je, salah tak apa, it's okay. Anyone? What is the value of X? I'm still waiting for you guys to answer. What's the value of X?
Oh,
Pardon? You were saying?
J,
Yes.
X2 yang Q bahkan.
Yeah, X is Q. Yang ini kita ganti so that we can represent it with something. We cannot represent it dengan Q. Sebab kalau sini Q, sini pun akan jadi Q. 100 minus Q, you can't be doing that. That's why we let this, benda ni akan dah jadi satu markah. Okay? So what's the value of X?
CJ berapa titik perpuluhan?
2.
38.47.
Yap, 38.47. Okay, in chemistry, korang nak buat dekat atas ni semua kan? Yang part-part atas ni calculation, you can do lah 3 to 4 decimal places. Yang last ni, keep it 2 decimal places atau maximum pun 3 lah. Okay, tapi paling, a very nice answer is 2 decimal places. So, the moment you guys know what is X, adakah X value dekat sini and value of relative abundance of BB191 is also 38.47? Sama kan? This one and this one.
Ya, sama.
Yeah, the moment sini sama, you guys definitely know the relative abundance untuk BB191 adalah 38.47. So the moment that is the answer, korang boleh cari untuk BB193, right? 100 tolak 38.47. Nah, you guys will get an answer. Okay? Ada apa-apa soalan?
Perlu letak simbol percentage kah hujung jawapan?
Oh,
Perlu percentage.
you mean jawapan yang ini kan?
Perlu letak percentage kah? Simbol percentage di ujung.
Okay. Kalau relative abundance is best for you to write 38.47%, okay? Alright, jangan lupa ya, percentage over here. Sini pun jawapan korang, percentage over here, okay? Alright. Now, that is case number 1. When we look at these kind of questions, number 1, list down what is the respective relative atomic mass yang diberi. Number 2, write down the formula. Identify mana satu yang missing. Okay, summation ni maksud dia untuk yang ini tambah dengan yang ini. Okay, number 3, kalau you nak find what is Q, you let each abundance dengan satu alphabet. Okay, kalau ada 3 over here, you guys can always use X, Y, Z. Jangan risau. But it's up to you guys, okay? Number 4, calculation must be very perfect and you guys can keep it to 3 to 4 decimal places to get an answer macam ni yang paling dekat dengan jawapan. Schema, okay. Now, I just want to highlight over here, do you guys realize tak? Dekat sini kan dia bagi BB191 equals to, dia punya relative atomic mass is 191.021. You know why is it so? Dalam chemistry, when it's 191.021, it will always incline towards the most atau nearest number. 191 sini dekat dengan yang ini kan? Don't tell me 191 is close to this. That is the reason they call it BB191 because yang ini paling close dengan ni. This kind of questions will come out in your UPS. They'll ask you, let's say BB192, what is the relative atomic mass? A, 191.1, B, 192.01, C, 193 point something. Definitely is B kan sebab dia paling dekat dengan 192. Same case over here, 193 paling dekat. 193.025 is very close to 193. That's why that is how it is. Okay? Any questions before we move on? Part ni sangat penting tau. Sometimes you'll go up to 7, 5 ke 7 markah pun boleh. Any questions before we move on to the next?
CJ.
Yes.
Apa jadi kalau kita setkan BB193 jadi X? Bolehkah?
BB terbalikkan.
Kalau terbalikan sama je, bolehkah? Kak, skema jawapan ada apakah entah?
Maksud dia, you want to make this, what is the question again?
Contoh lah kan kalau lah kan setter buat BB193 adalah X. Jawapan
Boleh
masih juga diterima.
Okay, jawapan dia akan just terbalik. Tapi always remember, take the lowest number. Ikut turutan. Try to ikut turutan. Kalau dia bagi BB191 first, ikut turutan dia jadi X. Okay? Tapi I understand sometimes you guys put this as X. I do really understand. Okay? Try to ikut turutan. Jawapan usually takkan differ. Tapi kalau differ, dia punya skema akan jadi dual. Maksud dia, this jawapan will be accepted, another jawapan pun boleh be accepted. Okay? Dia ada dua case. Number one, you letak mana-mana pun, jawapan dia akan tetap sama. Atau number two, jawapan dia akan just twist. Like A for B and B for A. So, itu depending on schema. Usually, you just follow the sequence. Kalau yang ini first datang, so you punya jawapan pun yang ni akan jadi first. Okay? Don't jumble up the things. Alright?
Okay.
Alright, thank you. Now I shall move on to the next one if there's no questions. Okay. Now, here are some tips. Okay. Here are some tips for you guys to answer this kind of questions. Okay, guys, benda ni amat pendek tau, this subtopic. Tapi benda ni sometimes will go very high marks or will go very confusing. Okay. Number one, the first tip is average lawan relative. What is the difference? When you talk about average, you have to put unit AMU. Let's say 100 AMU. AMU wajib when they ask average. Kalau tiada AMU, kosong markah. Next, kalau dia tanya relative, jangan letak unit. 100 cukup. Okay? Sebab itu tadi, they give you relative atomic mass, just a value. Tiada AMU. Okay? Over here, kalau average, ada AMU, which stands for atomic mass unit. Kalau relative, 100 je, tiada unit. That's number one. Number two, ratio. Kalau dia bagi ratio, okay. Tadi soalan, dia bagi mass kan? Dia tak bagi relative abundance. Now, kalau dia bagi ratio, let's say for example, dia tulis whatever soalan, lepas tu dia bagi BB-191 over BB-193 equals to 2.59. Okay, apa maksud dia sebenarnya? If you guys know, ratio adalah fraction kan? Atau division. So the moment it's called division, 2.59 bahagi 1, adakah ia sama dengan 2.59?
Iya.
Ya, sama je kan? So can I just represent the abundance of 2.59 goes to this and the abundance of 1 goes to this? Maksud dia, your Q1 for BB191 will go 2.59, sorry, 2.59, and for Q2 atau BB193 will go 1. So maksud dia, you punya EQ atau total abundance will go 3.59. Itu je maksud dia. You guys just have to know how to interpret the questions. Okay? That is number 2. Next, let's go to number 3. Number 3, we are talking about formula. Okay, formula, the same thing I'm going to repeat over here. Wajib tulis, because in chemistry, if you don't write the formulas, no marks will be awarded. Number 1, that's the situation. Or number 2, kalau tak tulis formula, mungkin dalam kerja, your marks will be awarded, but then untuk formula, no marks. Okay? Formula wajib. Okay. Now, tadi kan, before I go to the last part, tadi we have talked about here, right? Iki me iki. Okay, now, if they were to ask you what is the definition of average atomic mass, you guys can write this down. Will be given marks. Tak tahu dia punya full term pun tak apa. Yang penting write this, write this, write this. Kalau yang ini je tapi tiada yang ni, kosong markah. You guys have to write all three. This one, what is the meaning of Q, what's the meaning of M? If they ask, the definition of average atomic mass. Okay? Now, let's go to the last part. I'm sorry. Last part for this. Now, when we are talking about unknowns kan, when we are specifically talking about unknowns, you can represent it as X, Y, atau Z. Okay, that's case number 1. Maksud dia, you have more than 2 unknowns that you need to find. You can put it X, Y, Z, or whatsoever, A, B, C. But right now, that's case number 1. Case number 2 is when you're talking about 2 cases, which means ada 2 je. Macam tadi kita belajar 2 je. So you can definitely put X for one and 100 minus x untuk the second one. Kenapa? To make your life super easy. Okay? And don't ever forget the last point, relative abundance for E key yang bawah ni kan, the moment it comes percentage is 100. Jangan risau pasal apa-apa, just put 100. Unless it comes like this. Nah, kalau macam ni dia bukan 100. Kalau macam ni dia 3.59. Okay, tengok soalan tu betul-betul. Alright. Now, shall we move on to the last part?
Boleh?
Alright. Okay. Now, this one teramat sangat penting. Kenapa? Tanpa ni, you guys won't be doing any calculation for your 1.3. 1.3 is stoichiometry. Soalan tu dekat 10 to 15 markah I think when I was in SEM 1. Keluar PSPM. Okay? So, legit, chapter 1 for SEM 1 keluar 20 markah. Without that 20 marks, A is just, I'm sorry. Okay? So, part ni paling penting. So basically, senang je. You guys have to know how to calculate number of mole. You guys have to know this, this, and this. Tiga benda ni, if you guys know, a lot of problems settle. Now, number of mole, number one is mass over molar mass. It's also equals to number two, volume over molar volume. Now, there's two different conditions for molar volume. Number one is in STP atau standard temperature and pressure. Standard maksudnya you have to use 22.4 liter per mole. Another one is in RTP. Maksudnya you must use 24.0 liter per mole. Okay, kena tahu which condition dia bagi. Okay. So room temperature usually dia akan bagi 27 degrees Celsius or whatsoever. You guys definitely know it's going to be RTP. STP, they're going to state that STP atau 180 m and so on. Okay, that's number two. Number three, number of particles divided by number of Avogadro. Okay, number of Avogadro where you can find. You can find in the formula list atau constant list yang I dah bagi hari tu di WhatsApp. So you will get what is the number of Avogadro, fill it in, make sure it's the exact number, then you can find number of particles atau you can find number of mole. Benda ni, this chain over here is extremely important. Okay? Right guys. That is for the first topic for our chapter 1. Paling mula sekali. Chapter 1 ni will take 1 month plus for you to finish because 1.3 is extremely big. Okay? This is just one of the basics and very important sebab everything dalam ni, the moment they twist the question, markah akan lebih banyak. Okay? Please bear that in mind. Number 2, make sure you guys know your formulas very well. Okay guys. Any questions? Okay, I think if there's no questions, you guys can leave. But if there's any questions, you guys can still stay and ask me. Or if you guys have questions later on, you guys can just WhatsApp me. And after this, I'll post the homeworks on our WhatsApp group within 12 hours, by which within around 9:30 esok pagi, have to pass it up to me. Okay? Thank you guys.
Okay, CJ.
Thank
Alright.
you, CJ.
Thank you.
Thank you, CJ.
Thank
Thank
you.
you.
Thank you.
Thank you.